So we're in the lab space. We're going to set up a run on our icon16 instrument. This is going to be a standard library prep master mix. We're going to take some reagents and we're going to pull them together to make our PCR master mix. We'll then load it on the icon16 and we'll walk you through there what we're going to set up for our AutoNorm run. So I'm going to grab some reagents. Perfect. So I pulled a cold block out of our fridge. It has all the components as one might envision for your standard PCR library prep. We have our adapter ligated cDNA here. We have our PCR master mix. We have our index primers, or at least our equivalent of index primers. A little bit of SYBR Green to add as our green fluorescence dye. This will help monitor the traces in real time, and some water. So I will just be making a master mix. Assume this is your standard library prep kit reagents, so nothing fancy here. All right. So I have 4 reactions here, so I'm going to be making a bulk master mix using the components, and then I will add in the cDNA template last. Perfect. So now what I'm going to do is I'm going to be making my PCR master mix and mixing it with our adapter ligated cDNA. So I have 4 samples here. They're ranging from high concentration or high inputs, so 100 nanograms, down to low inputs, 0.2 nanograms. As you would expect with your standard library prep, these various inputs would require different cycle numbers, which will require the use of multiple thermocyclers to achieve the same outcome. But here, what we're going to demonstrate with icon16 with AutoNorm is that we can run all 4 sample inputs at the same time. They will all cycle to their respective cycle numbers, and all will trigger AutoNorm at their respective times. So all will be normalized at the end of your PCR run. All right, perfect. Now I'm just going to label the tube and then we'll get going. All right, now let's go load this on the. All right, so we have our pre-made PCR master mix that's mixed in with our adapter ligated cDNA. We're going to open the drawer. Now this is where we can load in our strip tube. So load it in right here. We will then close the drawer. So here we already have our protocol preloaded. When we are running AutoNorm, we will set a max number of cycles, but this is going to be more cycles than what is actually going to be needed to achieve AutoNorm. So we have selected slope for this AutoNorm run here, which will basically identify where along the PCR curve this inflection point is occurring, and then we'll stop the cycle after the maximum inflection point has been attained. But there are other AutoNorm modes to choose from, and all of these will be depending on your application. Now that we have our AutoNorm enabled and our thermocycling program set up, we are going to go to the sample layout. We're going to select the wells that we're running, which are these 4 wells here. We have everything in place, so we're going to hit run. You can define a name for your run. So I'm just gonna say today's date. Perfect. And now we're gonna run the experiment. So the run is now ongoing. We'll come back in a few minutes and see how the tracers are going for each of our samples. All right, welcome back. We're checking in on the status of our run. So our run is still ongoing, but as you recall, we had 4 samples ranging from high input of 100 nanograms down to our low input of 0.2 nanograms. What we're seeing here is that we are having some wells that are triggering AutoNorm and stopping the run. So as you can see here, this green sample is equivalent to our high input sample, which is our 100 nanogram input. So as you can see, this well terminated at the end of cycle 3. You can also see it terminate at the temperature graph below, because as you recall in our run profile, after AutoNorm is set, it will exit out of this cycling loop and do the last 2 steps of the protocol, which is our final 1-minute extension and this infinite hold. This purple well has just terminated as well. So this is our second highest input. You can see here, this well just ended at the end of cycle 7. And you can see that as noted by the cold hold in this well. Now these 2 wells, which are our low input samples, these are still continuing to run, but now these wells are effectively done. They're at a cold hold, but that doesn't affect the performance of the other remaining wells. So while we're working here with adapter ligated cDNA, you can imagine this for any kind of application. If you have some degraded FFPE samples where you thought 10 cycles was perfect, but you might need a couple more because the degradation is much more apparent, this is where AutoNorm is going to come in handy, where you can continuously let your samples run until they hit the right point, and AutoNorm knows where exactly to stop your samples. Well, welcome back again. We see here that our run is finally complete. All 4 samples have successfully machine. Because everything has roughly the same yield, I can move forward to do equal volume pooling. So that way I can move forward with 1 individual pool cleanup as opposed to doing 4 individual cleanups followed by 4 individual quantifications before normalizing them together for sequencing. While it's only 4 samples here, you can only imagine what that could look like in a 96 well plate format, where instead of having to do 96 individual cleanups and quantifications, you could do the same thing here, where you can pool things together in equal volume and do an individual cleanup and quantification. During the cleanup process, once things are pulled together, your standard cleanup processes will remove your SYBR Green or any other green fluorescent dye in there, ensuring that you have purified, amplified material. And once you do the cleanup and do the individual quantification, the purified libraries are ready to go for sequencing. So AutoNorm really does help simplify your workflows. It's as easy as we've made it up here, and hopefully you get to try this with your own workflows one day.